So the compare objects problem is pretty. I like it a lot because I think it really kind of pushes the envelope on like just thinking through what exactly you're testing for here. So essentially, and I guess everyone's read this, so it shouldn't be too much surprise. We take in two things. We call it obj1 and obj2. And then we just need to go back and return. We just got to go back and check to see if things are equal or not. One thing that we cannot do is obviously something like this will seem very standard, but as you'll learn on Thursday, this does not work for JavaScript objects, or at least it doesn't work the way that you think it does. Equality for objects is, or rather, equality for all complex data types is it's a bit more nuanced than just does it have the same identical values. Um, so we need to kind of go through and actually check things a little bit more. I guess a little bit more manually. And so I think for the most part, the I think Reed's code does it correctly. The idea is when we're checking for equality or checking for certain things, pretty much the idea is like we're trying to find things that prove us wrong, right? Like we're trying to find at least one difference in the comparison between the two objects. For example, if both things, if we find 10 differences between these two objects, it's pretty much the same as finding one difference. And so, from our side, we're just looking for that first difference, and if we can't find it, then at the end of it, we'll return true at the end of the code. Everything but before that, like we did, we're just trying to see if it's false. So the code that I'm gonna write is actually not much different than Reed's. It's probably just shorter because of syntax reasons, honestly. But let's just make sure that we're all understanding the logic behind this. Okay, if we're gonna compare, if we're gonna compare object one and key one, well, let's create or let's at least create one loop of saying, hey, let key one in obj1. So we're gonna go through every single key in obj1, and then we just kind of need to basically check to see, okay, if obj1 index of key one does not equal obj2 index of key one, we return false. And then all I need to do is I copy this again, and I'm changing this now to, we'll call it key 2, object 2, object 1 key 2, and object 2 key 2. And this is pretty much, sorry, this is probably, I went through this a little bit fast. But this is pretty much all we need to do to get the right solution here. Let's run it to be sure, but this should work more or less. More. Okay, great. And it's set up structurally very similar to a Reed had. But I think the one thing here that I wanted to kind of call out is, I think in Reed's code, Reed had an extra step here where he checked to see if key 1 was inside object 2. Right, Reed? I think you did that, right?
Yeah, I did that.
Yeah. There's actually no need to do that. And the reason why is because if we're thinking about the nature of an object, or specifically if we're trying to think, does the same key value pair exist across both objects? Well, the easiest way for us to do it is actually not by comparing the keys, but by comparing the values. And what I mean by that is, let's say we're trying to compare two key value pairs, and they both exist and they exist identically in two objects. The key in, or rather, the value for this key will be the same in object 2 as it is in object 1. If the values are different, then we have a difference. If the keys are different, well, that means the values are inherently also going to be different, or at least they won't be processed correctly, or at least they won't compare equally. And I guess the thing here is, and the line that I've highlighted is the one that maybe takes a bit of thinking to just kind of wrap your mind around. But essentially here, when we're trying to compare two objects, we don't actually need to check to see if the key is the same, and then check if the value is the same. We can just check to see if the value is the same or not. The analogy here would be to go back to the example of a dictionary, right? Is if I have a copy of Merriam-Webster's dictionary and I have another Oxford dictionary, and I say, hey, do these two dictionaries define the same word in two different ways? Well, the first thing you could do is you could say, okay, well, let's say I'm trying to check for the word house, right? You could say, hey, does Merriam have the word house, and does Oxford have the word house. But then you would still need to go and say, okay, now what's the definition of the word house in both dictionaries? Well, the point here is that we can actually just bypass that first step altogether and just say, okay, well, does uh like what's like is the definition of house in one dictionary equal to the definition of house in the other dictionary? And it's not much time savings from a theoretical standpoint. But what it does is it does allow us to kind of get around just doing a little bit less computational work. And it also helps us get to the root of what we're trying to compare. And that's kind of a thing that you'll see more as we work on more and more complex problems. There's always a lot of work you could do. But if you just kind of step back and think about what we're actually trying to figure out, you actually realize you can probably minimize a lot of the work that you do end up doing, right? And so comparing keys is actually not very useful here. We can go directly to comparing values because, once again, values, equal values inherently means that the keys are going to be equal. Is this making sense to folks?
I guess my only question with that, it's only going to be comparing key one for both objects, right?
Yes.
Would it move on to the next one, or is it just going to? Maybe I didn't read the README right. Is it going to still compare like every key in each object?
Well, it doesn't compare the keys directly. What it does is it compares the values, right?
Mm-hmm.
And what we know here is that if these two values are equal, it means we got two equal values. It means the keys have to be equal. There's no ways for us to get two values without having to because the way we get the value is by using key one here, and the way we get the value is by using key one here. If the values are equal, then it means the keys have to be equal. Right? Because it's the same exact value. It's the same exact variable in both instances.
Okay. But what if object one and object two had more than one key value pair?
What do you mean?
So in line 5, that's comparing the key value pair for object 1 versus the key value pair for object 2.
Mm-hmm.
Yeah. What if there was a second key value pair for each of those objects?
Okay.
Would it just stop at the first key?
Well, if it finds a false, it would return false, right? And then the function would end. If it doesn't, then it would just go. Remember how this for and loop is actually going through every single key in object 1?
Yeah, okay.
So it just if it's not false, so if it's true, then this just doesn't exist, and then we just keep going through this loop over and over again until we've exhausted every single key in object 1.
Okay.
So this is the first time that I'm also seeing objects. David, I'm just curious. Can you just clarify? This is the for in loop, right?
Yep.
Okay, and key, that's a keyword with like this function that's happening, like it knows key 1, like you don't have to.
Okay. I mean, I can call this whatever I want, right? It's just a variable name. So actually, one of the things we can do here is we can actually use the same variable in both cases, because this variable thing we're testing, this exists independently for each for loop. Because remember how we talked about variable and scoping. When we talk about scope, like the thing we're testing here only exists within the confines of this for loop here, and then this variable for thing we're testing only exists within the confines of lines 10 through 14 for this for loop here. And so we can call this whatever we want. The only thing here that's reserved are the for, let, and the in keyword. Everything else is up to us.
Okay. Thank you.
Yep.
For like how far we got, we use the object.keys like function and said that if they were not equal to each other, then return false. But I hadn't made it much farther than that.
How are you comparing the object.keys?
Would you like me
Sure.
to
Yeah.
show? Okay. Okay. Okay, so ignore like the bottom part.
Sure.
But this is what I did.
Yeah. That's not gonna work.
Would that not always work?
It doesn't work because on line 3 there, and like I said, like we're gonna talk more about this on Thursday. object.keys gives you back an array, and so you're comparing two arrays. And the kind of the punchline here is that in JavaScript you can't compare two complex data types with the triple equal sign, or at least the equal sign doesn't mean what you think it means.
Okay.
So that's like a
Okay.
fundamental flaw, I guess. Like if line 3 doesn't work, then the rest of your code is going to be built on that. Then it's going to run into problems down the road.
Okay.
Right. And so here, let me share my screen again really quickly. Okay. Oh wait. Okay. So here, if I okay, so here if I do a console.log and I say 8 equals 8, then I do something like like David equals David. Right. This gives me true and true. The problem is if I try to do something like this, and here let's just do like a very simple example. Let's compare two empty arrays. We run it. We're going to get back false. And if we get even like 1, 2, 3, and here we compare 1, 2, 3, we get back false. And so this is what I mean when I say that your line 3, like even if you get two objects with the same identical keys, you're gonna get back two arrays with the same strings in them. When you compare them, it's gonna be false.
Okay.
And we'll talk about why
Got
that is
that.
on more on Thursday. But that's the reason why I'm saying like like your first assumption is not going to give you the answer that you think it's going to give you.
Okay.
Yeah, I know it's a bit disappointing.
Can you hear?
But it's no fault of
Hearing
your
my
own.
voice?
It's no fault. It's no fault of your own. It's just like it's something that that we'll talk about, but it's a little bit. It has to do with the way that computers, or I guess JavaScript, kind of mandates the way that they store variables, and the way that we kind of keep them or preserve them for use in different parts of the code.
Okay. Yeah, I'll just have to learn this.
Yeah. Okay. I think let's see what else was there. One thing I'll also say is that as we were going through the code, I think I saw quite a few people still have returns in the middle of their functions. And just so you guys know, remember, once a function hits a line that starts with a return, it's going to execute that line, but the function is going to end immediately thereafter. So do not put return at a point in your code or a point in your function unless you want the function to potentially end right there. I think that was still an issue, as I think I saw some of the groups having as well. But the hard part is everyone ended up at different places in the code. Everyone got through number 1, which is great. But I think people all in different places on the code. So doing a group review is a little bit tricky because I don't want to once again review things that people haven't seen yet. But I guess were there any kind of high level or conceptual questions people have about any of the problems? Like I'll talk through solutions on like a request basis, but not as like a general like, oh hey, here's all the solutions kind of thing.
I mean, I did have a question about the second compare object.
Sure.
Can I share my screen?
Absolutely, go ahead.
Okay. So I was trying to do this. So yeah, so I guess if I had, and I didn't test this out, but if I had compared the value here instead of just, I was trying to, would this theoretically work? So I was like trying to compare, if I had turned these into values, would this be a viable solution for this problem, or is this totally off?
It would not work. So like okay, let's try to figure out why, right? The first thing is like at the second half of line 6 there, you're more or less making the same error that we were just showing, that when you compare two objects, when you use triple equals, they don't compare the way that you think they do, and so the second half of that and statement is just, it's not going to give you what you think it's going to give you.
Okay.
Because you're comparing the objects as a whole, right? And really, if that worked, then you don't need anything else in your code. You could just do object one equals object two and kind of go home, right? Like if it compared the quality the way that we assumed it, the way that we assume it does.
Gotcha.
The other thing is when you compare key one to key two, well, comparing the keys doesn't tell us anything about the values, right? Like two dictionaries could have the same word but have different definitions for those words, right? And so you're saying, hey, both dictionaries have the same word, but you're not checking to see if they're defined the same way. So that's kind of one issue as is on line 6. The other thing I'll say is that on line 4, you're saying let's go through every key in the object 1. And then on line 5, you're saying is for every key in object 1, let's go through every key in object 2. And there's really no need for that, right? Like if I have a dictionary with 10 words here and I have another dictionary with 10 words there, I only need to check each word. I should only need to check, let's say theoretically, at most 20 times, right?
Gotcha. Yeah, this is
Yeah.
totally okay. I see
And
it now. This
and
is
so what you're
totally
doing is you're checking like 10 square. You're checking 100 times.
Gotcha. Okay.
Yeah.
I was trying to put these on the same level, so it would have had to be like let this bit key in one, and then maybe say like and key two in obj two or something like that. But this is like nested, so that's already totally ridiculous. Okay.
Yeah. The other thing that's also actually, thanks for bringing it up. There's actually something that just to highlight. When you use a for loop, you really shouldn't assume any sort of order. What I mean by that is, just know that the loop will go through every key in your object, but don't think that, oh, like this key's gonna be first, then it'll be this key, then it'll be this key, then it'll be this key.
Gotcha. Right.
Because depending on how JavaScript is implemented in certain environments, that order could change over time. And so that's kind of another rule of actually the main difference between arrays and objects, really. Arrays have indexes and objects have keys. But the other main one is that if you need to preserve some type of order, like, hey, this thing comes first or this thing comes before this thing, use an array. Objects are not meant to denote order in any way, and you could get in trouble if you try to assume that. Because when you delete things from objects, it actually, in some environments, it actually changes the orders of the way the keys get processed. So as a rule of thumb, just don't do it. Like don't make the assumption that the way that the order in which it goes through the keys for one run the for loop is going to be how it always goes through the run for the for loop.
Okay.
Cool. Any other questions?
Yeah, I had a question on the dog problem. It was not that bad, but the parameters, they had a trick in the parameters. One of the parameters could have been sent, the age could have been sent for the name. The only way I could think to handle that is perhaps var args, and I wanted to see what you thought about that.
Yeah, that could work. Like trying to process the arguments directly too. If you want to share your screen, I can just do like a quick read through. There.
Hold on just a second.
Yeah.
There you go. Can you see it?
Yep.
What I came up with is not var args. I simply assign name or Steve to the name if it was not defined and age is 0. But in the test data, they actually send the age and no name.
Yep.
So you're getting the name as a 3.
Yep.
So I ended up testing name to see if it was a string, which I'm sure there's a lot better way to do that.
I mean, define better, right? Like it's,
well,
you're,
if you said var args and you said basically if the number of arguments is 1, then I'll assume that you're sending me an age. That's the only other thing I could think of.
Yep. Yeah, but I guess why would that be better than what you're doing now?
Well, I don't know. It just seems like I got a lot of lines of code here, and maybe I could simplify a little. But
Uh, yeah, you could. I guess like here you have what 4 lines there between lines three and 6. Um, like what you're doing is not wrong, and it's actually not like inefficient, right? Because you really think about like even if you use var args or something, like you're still fundamentally doing the same thing, right? You're checking one data point about the arguments. In var args, you're just checking the number of data points. Here, you're just checking the type of for one of the data points, and then depending on what that says, you then kind of reassign the values differently, right? So in both scenarios, you're actually doing pretty much the same thing, and so we could use var args, but I would actually argue that it's not like there's no performance or really complexity like in both the computing sense and also from a human sense. There's not like a much of an advantage to doing it with var args than this. Um, so that's kind of my 2 cents there. Um, yeah.
okay, well, that's about the only thing I could think of so far. But that's the only question I've got.
Cool. All right. Any other questions from folks?